Good morning, everyone. Good morning. Boy, have we been in the rain. Boy, oh boy, oh boy, have we been in the rain. Got river flood warnings up pretty much everywhere. So today, in this part of our Solar 101, we're gonna take a brief look at the three different size systems. I'm taking a look at my garden. I've got an armadillo going through here I need to address. You can see where that little joker's been digging here, and all through there. Getting a little destructive. I'm not sure how I'm going to address it, but anyway, we're going to take a look at three different size systems that I have, and we're going to talk through components and system sizing based on the different voltages and ampages, and start to get you a correlation between power or current or watts in usage. Squirrel coming down the tree. Beautiful morning. So much work to do out here. So much stuff I got to do. These are my jack-o'-lanterns, and they're really starting to take off. Boy, everything is overgrown. Anyway, got work to do, so let's stay focused. Hard for me not to make observations on what I need to do. All that rain's not my beets over that were going to flower. On top of that, the armadillo's rooting around them, and I'm not happy with that. All right, so let's stay focused here. So the first system we're going to look at, we're going to talk about a couple of aspects of this. Okay, we got one of these little 15-watt panels, and again, on the back of all of these panels, you have your data in reference to what its production is. 15 watts and 22 volts open circuit, which means if you were to just connect the hot wire or the positive wire and the negative wire, and you were able to measure that voltage, you would get 22 volts. But anything within some kind of a reasonable circuit that's put together, ergo connected to a battery and such, you're going to end up with a 18, 19 volt, 20 volt, depending upon the amount of sun that's being put into it. All right, so first thing we want to do is notice the wire sizing that I've got going on here. Let me see if I put my knee down on this rock and not look at that huge amount of water there. Wire sizing. I got some number 12 wire here, and this is an AWG, which means you can see down there it's multi-stranded. One of the concepts you want to know about electricity is electricity does not, or the electrons do not flow inside a copper wire. It flows on the outside. So the more surface area that you have in a wire, the better it conducts, because there's more surface area for the electrons to flow on. So you know, we're bouncing around in a lot of different topics, but the point is, this is how I think. You know, when the time is opportune to express something or explain something, that's when I do. All right, so lights are on. Lights are green because it's sensing light and the battery's charged. So I've got one of these little, and it doesn't have a label, but I think it's about a 2.5 amp hour battery. You can pick these up at your farm supply store. This is a 12 volt battery, and this is a charge controller that's designed for a 12 volt system. You see it says 12 volts DC, and its maximum amperage in solar in and load out is 10 amps. So this can handle up to 120 watts. Now, I don't have that much wattage on this panel. It's only 15, because the amount of wattage that this demand or the load is on here is not requiring that, and there's enough amp hours stored in here that even on cloudy days this thing will produce enough power to keep this thing charged and keep this electrified. Now, what is the missing component here? What are we missing? Anybody got a answer? I'll wait while you type it in the comments. There's 4 main components. We're missing, of course I'm going to tell you, we're missing an inverter, because this load is designed to directly handle a 12 volt system. So I don't need to invert this from DC to AC. We're using DC to power this fencing charger because of how it's designed for its output application. Now it really converts that up into a much higher voltage and a small ampage, but high voltage to push through a whole lot more wiring for very long distances of travel. It's still DC, but it's extremely high voltage. And, you know, they make different charge controllers. But notice, okay, so for my wire sizing, I've got a number 10 wire taking me down to my grounding rod, which allows the current or the electricity flow on the aluminum wire. And then once something creates the connection between the wire and the ground, that completes the circuit, allowing the electricity to, whoops, let's not touch that, flow back through the ground, come up through here, and complete the circuit, thus giving whatever's being the conductor, generally an animal or such, or sometimes it's grasses. Now I just took the weed eater yesterday and went around everywhere and cleaned it out because we don't need it grounding out on a piece of grass or something. So smaller, very small system, and there you go. We've got one done. All right, let's get. Actually, there's 4 I could show you. Let's step up. Let's go over here, because there's another. I realize it. I got a lot of solar out here. This is as simple as you get too, and I won't get into the entire detail of it because it's just to set an example. But I got a tiny little, and that's probably going to be about a 1.5 volt solar cell, and this is a Morpheus film. They use a Morpheus film on a lot of these because, you know, the silicone. Now some of them they do use silicone on, but the yeah, that's a Morpheus film. That is not silicone, but sometimes they'll use silicone on these, on the more expensive ones. But inside here is a little rechargeable battery, and there's a tiny little bit of circuitry to control the charge into the battery. And then its only purpose is a direct charge of light. So it does not have an optical sensor. These things are done where it senses the input of power here, so that if you you see the light come on. It's hard to see, but it's on in there. So it senses the input. So when it no longer receives input, it allows the battery to operate the light. Tiny little system, but not where we want to go. But the point is there to try and understand the differences. Now the next system I'm going to show you is the next step up. We have a 100 watt panel right here that I use for my battery system. Also notice I have a couple of number 12 AUG. These are 12 AUG wires. AWG. No, they're not 10. These are number 10. These are number 10. That's number 12, maybe 14. I can't read the printing on the wiring anymore. But it's not number 10. It's small. In other words, the wiring size is big enough to handle the wattage coming through. Now let's look at the voltage here. Open circuit voltage, if you were just to connect positive negative, is 22.95 at 5.91 amps short circuit current. There's your ampage. But then what you really want to look at is the rated. What they're listing is the rated, and that's 18.39 volts and 5.51, or is that 5.31? 5.51. I don't have my reading glasses on. Amps on that. So, we're pretty much near that 100. It's doing its math at 101.27 watts. Right there on the top. It's a 100-watt panel, and of course, it also gives you some more data. It says its entire maximum system voltage is 600 volts. Now that is that's an OSHA thing, that all of our electrical stuff in this country is rated up to 600 volts in order to be OSHA, or is it NEC? I forget which one is. National Electric Code, or probably it's National Electric Code. For safety. It's about safety. We're going to get into safety here in a minute, but also notice it's telling you what its fuse rating is. Its fuse rating is 10 amps right there. Okay? That's important. When we get done with this, the next discussion that we're going to do is going to be breaker ring and disconnects and breaker ring. But for today, we're just looking at different system sizes. Now, this is more like what you're going to be interested in, obviously, for an off-grid system. And what I have here, now let's get into the real numbers. I know I was throwing some easy numbers here. Nominal power 200. Let me see if I can get you focused in there. Nominal power 260 watts. Short circuit current is 8.99 amps. All right, and open circuit voltage was 38 volts, which is much higher. But the real voltage numbers that we want to do for our math are 8.45 amps and 30.78 volts. Okay, and then maximum system voltage. They've got this one designed for a couple of different. International Electric Code is 1,000 volts, and the United States, or Underwriters Laboratory right there, is saying 600 volts to meet those regulations. And then it tells you how much the panel weighs, which is about 42 pounds. So what you see is 1, 2, 3 panels in a string. Right? 3 panels in a string. That means we're going to add our voltage. So what did we just say? 30.78. So we got, let's just round it up to 31. So we got 31, 62, and 93 volts. 93 volts for that string. Then you add another string, and you're not going to add the volts, you're going to add the amps. So then we're going to take and we're going to add our 8.45 amps to come up with a 16, about a 17 amps that maxes out on this. Now, that in its own is separated, and we're going to, like I said, when we get into the breakerage here, we'll discuss that. But right now, we want to go in and take a look at the other components. So we have this size that's number 10. Now this is solar wire that comes on the panels, or if you have to connect them, I have to make these by getting MC4 connectors and making my connection into my disconnect box, or this is called a combiner box because I'm combining this string with this string. But let's talk about wire sizing. So this is all number 10 wire based on the voltage, which is 93 volts, and the ampage, which is fine for number 10 wire. But once you get in here, that wire size has to go up, and we've jumped up to number 8, and you can see I run the 2 wires in, and we're going to step inside here. God, it's sloppy. It's so beautiful out. Let's go in here. Had a nice warm fire this morning. And then we get over to my mess of a system here, and we come in, and the first stop is our charge controller, and that's the Schneider is what I'm using. I also have several other charge controllers, and when we get into each component's discussion, that we'll get into a couple more sizes of charge controllers and the voltages with those. But this is an MPPT 60 amps, so that's up to, so it gives you its input rating and output rating, 150 volts at 60 amps. So what does that mean? Let's step back out real quick. So that charge controller, if one string is 93 volts, I could put another panel to increase that voltage, right? I could increase that voltage up to 120. Is it possible that I could throw in a 5th panel? Mathematically, just barely, no. Because then you're talking we would be at what, 155 volts. And with the open circuit rating being much higher than that, that would exceed the voltage of what my component is. So this is system sizing. We're going, okay, I could put 1 panel in, I could put 2 panels together, I could put 3 panels together in a string, or I could put 4 panels. But at some point or another, based on the panels, I cannot put a 5th because the math now exceeds what the rating is on the charge controller. Let's go back in here. Now, from there, I go to my inverter. Now there's different sizes of inverters, and like I said, it's all about what your output is needing. But I have a Connect sine wave 4024 that I'm using here. Notice I also keep my little cheapo multimeter here for checking voltages. Always ready to have it for my battery system. So here, the next component, this is the first system that you're seeing. All those other systems did not have inverters. I happen to have an inverter on this end because my loads are going to be AC, and as you can see, my computer's set up here require AC. My refrigerators and freezers require AC, and this is where your work is really done. As far as what you're going to use your entire system for. Okay, of course, this particular company, as well as many others, do their breakering as part of their system. So this, I have the breakers here between the different components, and like I said, we're going to discuss that in a different video. But let's also take a look, and I know it's a little bit of a cluster over here, but this is my radio cabinet. Some of you will have seen it, and you can see all my radios, all my ham radios. Oh no, one of my girls has gotten in here. I'm going to have to do something about that. But, alright, so this system, I've got another one of these little sun savers because I have matched that 100-watt panel to a charge controller that is rated for the 100 watts and into my batteries. Now I've got four batteries down here in this charge controller, or excuse me, in this system. What's missing in this system? So we've got a single 100-watt solar panel. I've got a charge controller that is rated for what I can produce out of that panel. You know, we've already done those numbers. So this does not require anything more than that same number. I think this is number 12 wire. Yeah, I think it's number 12 wire. 12 AUG wire. It's not 10. It's not. It might be 14, but I think it's 12 AUG. Anyway, all right. So I'm not going to pull out all my junk. I'm just going to tell you. So there's no inverter on these batteries because this is a 12-volt system to run. I'm working straight off the battery voltage, and many systems that you may do that as well if you know that's what your load is. But because our load for most of our household stuff is either 120 or 240 volts, we have a sized inverter to handle that. So down here, I don't need that, so I don't need the inverter. And if you could see it, and if my mess wasn't in the way, you could see that there are two wires, a positive wire and a negative wire, that come up into way back here in the back. And I'm not going to pull it out because it's a mess. But there's two what I call bus bars, and the negative goes to one bus bar, and the positive goes to another bus bar. Same thing that you're going to see inside an electrical box. And then all of my radios have their positive wires getting connected to the positive bus bar, and the negative wires getting connected to the negative bus bar, if that makes sense. So this is direct from batteries straight to the components, the loads, the things that I'm going to be using. I don't need to invert it. Over here is the only inverter that I'm using at the current time. And then we will talk about, when we talk about what kind of inverter you're going to want, we'll get into that when we talk about the inverters on their own. We're going to do a video on each of the four main components. So there are several examples of different systems, different wire sizing, because like I say, when you get in here, you can kind of see the number 8 wire. I'm not going to get into each of them. This is to put you in context, not connext, but context. and then let's take one last look at the batteries. As you can see, with the lighting being bad, the batteries are heavy duty cables. These are 2-aught. It's essentially all this is welding cable, and that's so that it can handle high ampage and lower voltage, because you don't have as much pressure in there. You need a bigger size cable. Now, are you going to necessarily need 2-aught? No. But notice the two big cables are even bigger. So the positive going up here to the inverter and the negative going up to the inverter are actually 4-aught. They're even bigger to handle the amount of current and ampage and wattage that's going to be required to convert to invert the DC into 240 volts. So there's your four different, several different sizes of systems and different kinds of applications, also with some clues into some wire sizing and such. And that will wrap up this portion of, I think it is, let's see, that's part 4. This is part 5. I'll get this one posted for you, and then I'm going to do part 6. Part 6 I think will be a little shorter, and we're going to discuss breakering. So We'll catch you in the next one.